and gentlemen, have a very good afternoon. Before commencing our forum for the day, we would like to have a short video about climate change. Thank you.
Which is the issue of climate change that has become one of the most frequently discussed topics.
Of weather events, floods, mass migration, drought, and depletion of water and food resources. Among the most prominent factors causing climate change is global warming resulting from pollution and the emission of carbon dioxide from factories, vehicles and aircraft, and other factors, as well as emission resulting from the combustion of fossil fuels, is one of the most important and main causes of climate change. Climate change began in 1970 when the world's population doubled, the economy grew, factories increased, and smoke emissions increased with it. Instead of increasing green spaces, humans cleared forests and cut trees that absorb toxic gases. The Paris Agreement, or COP21 or COP21, is the first global agreement on climate, and this agreement came after negotiations held during the United Nations Climate Change Conference 21 in Paris in 2015. The agreement was ratified by all 195 delegates present on 12 December 2015. How can the countries of the world and the countries of the Cooperation Council, especially the energy of electricity sectors, contribute to stopping climate change? The use of transportation that emits toxic gases can be reduced, energy consumption can be rationalized, and things can be recycled and used instead of being disposed of. It is also possible to save and reduce approximately 269 million tons of carbon emissions. If the Gulf Electricity Interconnection project is optimally utilized, this will have a significant impact on reducing the carbon footprint and carbon emissions as international best practices are applied, and the integration between traditional and renewable production sources is one of the benefits of the Gulf Electricity Interconnection project. All these solutions help reduce global warming.
Thank you all. Welcome you all to this afternoon's event about climate change and energy security forum. Before anything else, I would like to thank the Gulf Cooperation for Arab States for helping make this event possible. Today's forum will tackle the key impact made by climate change on the future of energy security and the current efforts being made to help bring a reduction in carbon footprint emissions. We'll also be talking about the important role that the GCCIA plays across grid interconnections and the process of integration between new renewable energy resources. Today, we are privileged to be graced by such a distinct panel of speakers in the field of power and energy. Our speakers for the forum are the moderator of this forum, Engineer Ahmed Al-Ibrahim, the CEO of GCCIA, GCC Interconnection Authority. We would also be having with us today Engineer Fatima Al-Fora Al-Shamisi, Energy Policy Executive Director at the Department of Energy in Abu Dhabi. Welcome. And Engineer Chris Peters, CEO of Elia Group, as well as we will have Mr. Pierre Bernand, CEO of FOSG, and Dr. Lawrence E. Jones, the Vice President, International Program in Edison Electric Institute from the USA. Also, we'll have with us today Dr. Anas Dalagi, Project Director and Middle East Manager at EDF, and Dr. Amro Al-Shurafa, Research Fellow in King Abdullah Petroleum Studies and Research Center. I would like now to invite Engineer Ahmed Al-Ibrahim to moderate this panel. Thank you.
Thank you. Assalamu alaikum wa rahmatullahi wa barakatuh. Thank you for being here in this forum, which is our first activity during the Expo Dubai 2020. First of all, I'd like to take this opportunity to congratulate the leadership of UAE on a very successful exhibition. This is a very great event to happen in UAE. So all the congratulations to UAE leadership and especially Dubai. Today our forum will talk about something which is a very important issue. Climate change, which is something happening to our world, something that has captured the attention of all the world. The COP21 in Paris was a significant event which had changed the direction, and we have set plans by all the countries to combat this climate change that we're going, so that we can preserve our planet. One of the big contributors, of course, to climate change, as per the research, is the CO2 and the emissions. The energy sector is one of the contributors to this. So all the leaders in the energy sector are taking plans and ways to change the way that we operate our energy sector. And here today, we would like to hear from experts from all over the world. We have experts from the region here, from Europe and from US, because this is like a global issue. It's not something that's local. All the countries in the world and all the organizations should cooperate, collaborate, so that we can reach these kind of common goals. So today we'll tackle that. We'll tackle how does it affect the energy security, because here we're all experts in the energy sector. How do our energy sector react with this? What are the plans that we're taking in order to contribute to mitigate the climate change issue? And what are the challenges that we're meeting? Because we have also to ensure that electricity flows to all our consumers. So what are the challenges that we have to ensure energy security while we are also taking plans for climate change? So I'm very, very pleased to moderate this panel and have such a distinguished group of panelists here from GCCIA, from Europe and from US. And this is the first time also that we do a hybrid event where we have people who are physical and people who are joining us through the virtual from Europe and US. So please excuse us if there are any kind of technical glitches. So this should be an interesting discussion. We will start with a short review and presentation and talk from each of our panelists, and following that there will be a dialogue about the issues and the subject that they talk about. So let me start with introducing our first panelist, Engineer Fatma Farah Shamsi. She is the Energy Policy Director in the Department of Energy in Abu Dhabi. Engineer Fatma, she has work experience in Dubai and Abu Dhabi. So we're very fortunate to have her here. Thank you, Engineer Fatma, for joining us. And we would like to hear your views about the issue and what are the plans and strategies that Abu Dhabi is taking in this regard. Can I have a presentation of Engineer Fatma, please?
afternoon, everybody, and thank you for organizing. Thank you for organizing this event. I'm delighted to join you in this climate change and energy security forum. This event is definitely important. The time is the right timing after the challenges we faced during 2020. And the place, maybe it's the right place where all the, I think, 192 countries joining together here. So thank you for selecting Dubai Expo, and welcome to UAE. Hope you enjoy your stay here and you enjoy your visit to the different pavilions in the Expo. Energy sector accounts for nearly 90% of CO2 emissions globally. It's a dominant contributor to climate change. Accelerated by the adaptation of the Paris Agreement in 2015, countries around the world are strengthening their effort towards decarbonization. Definitely, we have Glasgow discussion, and everybody is aware of the clauses what Paris Agreement have with regard to the net zero and the target of 2030. In this transformation process, uninterrupted provision of vital energy services is a high priority of every nation. Ensuring security of supply is imperative for economic growth and social development. Energy security is a key factor and a pillar that underpins effective energy policies. Energy transition is characterized by energy efficiency improvement, increasing rate of electrification, and rapid uptake of the renewable and clean energy. All of these issues impact on energy security. The energy efficiency increases energy security in a cost-effective manner. By reducing energy demand, efficiency reduces the likelihood of supply interruptions, because the only energy source that cannot be interrupted is the energy that is not used. Electrification would clearly reduce global vulnerability to oil shocks, but could also introduce new vulnerability and risk to the energy system. Ensuring electricity security moves to the heart of modern energy security. And with the rise of electrification, system flexibility needs will also rise. Without the development of technologies such as storage, designing the energy system with massive nuclear, renewable, clean energy will be of concern if we look to the economic factor of the sustainability. In addition, there are two other risks of energy transition. We are living through the perspective of a new vulnerability and geopolitical risk. And finally, cybersecurity risk is also understood from 2 points of view: the security of the supply itself, but also the security and the information related to citizens using the energy sector. Energy transformation is more than a simple transformation of energy sector. It leads work to a complete transformation of our society, social, economic, environmental impacts. The vulnerability is probably higher in our region, where dependence on the hydrocarbon economy, oil prices, is greatest. A long-term transformation of Gulf cooperation states economies, reducing reliance on the oil sector and building sustainable and stable economy through diversifying into other economic sectors, may allow the region to minimize the impact of the oil shock, ensuring more stable and predictable economic growth. Technological development in the energy have brought about new opportunity for low-cost, low-emission generation, options for energy storage, and increased efficiency for conventional technologies. In parallel, the falling price of renewable energy has fundamentally changed the global power system and accelerated renewable uptake beyond expectation, generating new challenges related to the variable nature of renewable and what we witnessed during the year 2021 of, again, raised unavailability of the material required for renewable. The opportunity to the GCC country is to look at the energy system as a whole, to consider the main driver of the climate change, the main driver of the energy sector, which is the climate change. We have to think on moving to a cleaner energy system rather than clean energy mix only. We can achieve near to net zero or achieving even net zero by utilizing the opportunities laid in circular carbon economy and the CCUS, in addition to clean energy sources and electrification. And that is what we are doing in Abu Dhabi. Energy has been at the center of Abu Dhabi unprecedented growth and remains key to its future expansion and diversification of the economy. As a leader in energy sector innovation, Abu Dhabi is positioning itself at the forefront of the global energy transition. At the global energy transition throughout this transformation, Abu Dhabi has been in the forefront of energy innovation, aspiring to create the world's first carbon neutral city, Masdar, building the first nuclear power projects in the GCC states, and focus investment in the renewable energy, with commissioning of Noor project and the coming 2 gigawatt in Al Dhafra, that has placed Abu Dhabi on the map as a leader in solar PV, not only pushing the limit of what can be achieved in renewable capacity, but pushing records in the price of power generation using renewable. Abu Dhabi has been pioneering in the field of CCUS in the region, with ADNOC Riyadh facility commissioned during the year 2016, has the capacity to capture 800,000 tons of CO2 annually. ADNOC is also proceeding with the expansion of the program for the utilization of the carbon CCUS to achieve almost 500% expansion by achieving 5 million tons a year of CO2. Generation source towards new clean sources and the massive electrification of final energy use in the sector, such as transportation, industrial, and building, are heavily dependent on stronger and more flexible power network. And a high level of interconnection will enable society to exchange and use clean energy at the highest level of efficiency, resilience, and reliability. I'm very happy to be here today and to be able to talk and to listen to my colleague, the expert here, on this subject, because we're all in this transition together and we are all facing the same issues, same challenges. We hope to learn from each other. Thank you.
interesting views of what's happening here in Abu Dhabi and the challenges and the kind of plans that you're doing. I have some interesting points, but we will give the chance to all the panelists to give their views before we start the round of questions. So let me introduce our next panelist, Mr. Chris Peters. He's the CEO of Elia Group with subsidiaries in Belgium, the Elia Transmission Belgium and Northern Germany, 50 Hertz. We've started collaborating and cooperating with Elia a long time ago, since 2008, since the start of the interconnection. And this is an ongoing cooperation. They bring wealth of expertise into this. And we are very eager to hear from Chris. What is his views about the climate change and how the energy sector, and especially our electricity, is contributing to that, and what are the challenges that we have to meet. So Chris, the floor is all yours.
Thank you. Thank you very much, Ahmed. And we are very, very honored that we can be here today. As you said, our relationship dates back from 2008, and we brought with us a picture. And as you can see on the picture, many people that are on that picture are in the room, both sides. So we have Elia people that are here in the room. So it's a relationship that has sustained for more than 10 years now. And actually, we were very happy yesterday when you joined us in the Belgian pavilion, and this was a nice moment of reconnecting after this COVID crisis. It was even so nice that some of our people started to dream about the future. And they were looking at how the future together could be even more brighter than the last 10 years that we had together. So, but jokes apart, maybe for those who don't know Elia that well, I will give a quick introduction on what we do, who we are, and then I dive into the most important elements of the sustainability, the renewables, the decarbonization, but also, of course, the security of supply that is so needed in this stage. So first of all, I think one thing that is very important is to understand that Elia has two affiliates, one in Belgium, one in Germany, and the essence of what we do is we work in the interest of society. So it is the combination of, on the one hand, it's a business. Of course, we do that and we earn our money by that, but actually we execute energy policies and we make sure that we support the energy transition by ensuring that interconnectors are built, and so that we execute what countries try to do. And interconnections, connecting people together, is very important. Another element that becomes more and more important is bringing in renewables, and in our case, a lot of renewables come from offshore. And so the activity that we have is broadening into offshore, both submarine cables and having cables to integrate more and more renewables into it. That mission is very important because it's not just about us in the system, it's also something where we create welfare for the societies that we serve. And the same is true, of course, for GT. In the sense that if you will, we keep on the lights, we make sure it's clean energy, and that's an important boost for the welfare, especially if we can do that in an efficient way. And that's an important part of our mission. And therefore as well, our activity continued, most of them actually during COVID. Unfortunately, we could not travel to you, but actually if you see in execution, all those big projects, we continue to execute them. So next to that, what you see is we're not only present in Belgium, we're also present in Germany, and that's actually an interesting aspect because both countries have similar challenges, but they have a very different context. If you look at the Belgian context, we have the situation where we have a history of being energy short, we had nuclear plants into the play, and relatively little renewable potential. If you look at 50 Hertz, it already has today 60% of renewables integrated, so one of the highest penetrations that you see in Europe in terms of renewable penetration, and they don't have hydro into that. So that makes a very interesting mix in terms of how do you manage such a complex system in such an environment, and we learn a lot from that combination of having on one hand a small country with many interconnections, and on the other hand a country which is actually one of the champions in terms of renewable integration. And so that is for us a very important element, but not only that, what we have done on purpose in Germany is we are the majority shareholder and so the strategic shareholder for 80%, but we asked the government to take a participation of 20% to ensure that we fulfill this mission of supporting the energy policy and making that transition, the Energiewende as they call it in Germany, to make that happen. So why is this a top priority, this energy transition for us? Well, it is a top priority, of course, because we have two entities sitting in Europe, and those two entities, they are actually depending on what is happening at the European level, more specifically the Green Deal. We have now more recently Fit for 55, so the targets that we have by 2030, and this is an important driver. Europe wants to be emission-free by 2050, and Germany has increased that ambition towards being zero emission by 2045. Well, if you look at that, we have 25 years left to make that happen. That's a huge challenge, and that means that we have to accelerate on everything what we do. And what is it what we do? Basically, there are two things that we need to get right. One is the infrastructure build-out needs to happen, and we need to build more and more interconnectors to make sure that we connect ourselves better to the rest of the world. A lot of people say, yeah, why are you building those interconnectors? And actually, interconnectors have an interesting attribute that we have learned over time. Interconnectors typically start their life as a pure element of security of supply. So that's what we saw in Europe. You had countries that were responsible with vertical integrated utilities to ensure that they had security of supply, but at some point of time they figured out by interconnecting with other countries, we actually can further increase that security of supply, because if we are in need and short within our country, we can actually call on the countries around us. Then what we saw was that at the moment of the unbundling, back in 1990, when Europe started to say, this needs to be unbundled, and so in that discussion, there was an economic drive. They said, actually, those interconnectors, they reduce cost of your system. So it's not only about security of supply, actually it's also very economic, because you can exchange energy and you can have this energy where it is cheapest produced and bring it then to the demand centers. And so there was a huge push to have an efficient energy system. And now what we see recently is actually the next step in that. The next step is if you have a system which is highly dependent on renewables, interconnectors ensure the balance of the system. Because what they do is they ensure that if wind is blowing on one side and on the other side, you still can make sure that everybody gets his fair share in that renewable energy. And so you can exchange energy over that and balance a system which is dependent on intermittent resources like most of the renewables, wind and sun are. And so you see that that evolution in interconnections is a very important evolution to see and to understand. It is a starting point of security of supply, but it is actually as well a pathway to have an efficient system and also to have a system which becomes more and more renewables and you still can keep in balance. You need to do a lot of other things, but that's a very important element that you need to get right. Second, that you need to get right, digitalization. Because the more renewables you will integrate into your system, the more that you will have variability in your system, and so you need to find a way to balance that. You either have storage, but there is not that little economic storage available in most places. Some have pump hydro you could have, which is relatively economic, but actually the most economic way to balance that is to use demand-side response, to ensure that people use the energy when it's available, midday when you have sun, and they actually use things like heating applications, charging cars, all these things at those moments, and that they then can actually count on what they have already needed, that they don't need it anymore at the moment that the sun goes down, at the moment that you have lower wind. And that's an important second dimension that you need to get right. First of all, infrastructure built out with more and more interconnectors, and the other one is one around digitalization. Now let's see what that means in terms of acceleration for us. Here you see a picture of what we have in terms of available interconnectors and offshore wind connections that we have. And so what you see today, Elia is having more or less 2 gigawatt of offshore wind connected to its grid. And we will add in the coming 10 years 5.5 gigawatt of additional wind energy to Belgium and to Germany. We have at this point of time order of magnitude 3 gigawatt of HVDC interconnectors in our system. We will scale it up in the next coming 10 years with an additional 4.5 gigawatt of HVDC interconnectors. Some of them are hybrid interconnectors, some of them are direct interconnectors, but so you see that we actually, in less than 10 years, we will actually more than double on both dimensions. So that's a very, very important element in that acceleration that we see happening. Let me give you an example of new complex technologies that we are using here. So what you see here is we are going to build in Belgium an energy island that will take the form of an energy hub. And let me maybe give a little bit of explanation of what it means, because this is really a game changer, like the hybrid interconnector was a game changer. So what have we seen in this offshore development? Well, in the offshore development, the first thing that you saw was people were connecting nearshore wind farms to the grid, integrating them in the grid, what we call radial connections. Quite effective, it seemed to be, and you saw that we could reduce costs quite drastically. Next step is, and Elia Group was the first, we still have the only one that is operational, hybrid interconnectors. You combine an interconnector and you have wind in feed on that interconnector. Result, your cable is almost fully used compared to a normal radial cable, which only has the moments that the wind blows, which is in our area between 40 and 50%. Other areas you could go up to 60%, but still you have a suboptimal use of the cable. Here you combine a cable that has wind in feed, and on top of that has the opportunity to use that as an interconnection at the moment that you have lower wind. And so that created another economical benefit and is reducing again the system cost. Next level here, the island, is the level where you basically say, I have on the island, first of all, I take the wind that is surrounding that island and I bundle it over there. And secondly, I connect myself to multiple countries. So it's not only to 2 countries that you connect, for instance, in our case, Denmark, Belgium, and the UK. And then all of a sudden you have all this optionality that you can send this wind to where you want, and if the wind is not there, that you can connect how you would like. And so that creates an enormous additional welfare that you have without having a lot of additional costs. And so that's the next stage, and we try to finish this project by 26, 28, integrating 3.5 gigawatt of additional wind power into the Belgian grid, but also connecting it to Denmark, connecting it to the UK. So an enormous ambitious project, but very important to do the next step into the decarbonization of society, because Belgium is a country, I would say, an ideal partner for the Middle East, because we're short in energy, so we're looking for countries that are long in energy, and you have not only had that in the past with fossil fuels, you will have that actually with green energy as well. And so we look for those partnerships to ensure that we can combine it. Some of them will be, of course, near to Belgium, Norway, Denmark, UK, the Netherlands. Some of them will be with countries that are more remote, but have, as we have seen in the presentation, have low cost of producing those renewable energy that can send this to us either by cables, and we have discussed some of these projects in the past already with you, either by we can have a real long-term partnership with you. Thank you very much.
Thank you very much, Chris. Very interesting perspective, and I think something that is like music to my ears is when you said that interconnected is a major part of what we need to do, and we need to build more and more interconnectors, and this is a business we're in. And actually this is a facilitator for energy transition and integrating of, so interconnectors are very, very important, and the grid is a very important part of our energy transition and making sure the plans can succeed. With that, let's go to our next panelist, and I'd like to test our technologies by connecting to one of our friends over the virtual. So I'll introduce our next panelist, Mr. Pierre Bernard. He's the CEO of the Friends of the Sustainable Grid. Can you hear us, Pierre? Can you hear us? I think Pierre cannot hear us.
Good morning. I don't know if you can hear me, but I hear nothing from where I am.
Okay. Can you hear us now?
No. I saw the slides, and I think Lawrence Jones is in the same situation. I have the impression you can hear me.
Yes.
Looks like. Okay. Morning or good afternoon, everybody. And as you can see, I'm not in Dubai, but I do have a nice picture of Dubai behind me. I'm willing to give my presentation if it works like that, but it sounds a little bit strange. You can say yes by showing your finger, or
we can hear you.
Okay, well, we can move. Apologies and hello to everybody. Some faces I recognize there. So I will let the host show the slides also. I think it will be easier as there are some technical issues. Maybe it's better that he can share the screen. So please go ahead.
Who's sharing the screen? Can you make the presentation from your side? Can you share it from your side? It's okay. It's okay.
You see the slides? Okay. Hello again. Apologies for the technical issues. I brought a couple of slides, relatively high level, because considering the title, I don't want to zoom too much in day-to-day technicalities. First, a quick introduction, and allow me to share a Chinese proverb I read a couple of years ago. When the wise man points at the moon, the fool looks at the finger. And when we talk about climate change and energy transition, do we really know why and where we are transitioning? Is it because climate change? Is it because we're creating a new paradigm? Is it just the normal course of life? There were other energy transitions before. Is it because fossil fuels are going away, disappearing, or maybe all the above? And the question I have is, should we not more thoroughly reconsider the way we are living? When we look at some numbers, for example, the Earth Overshoot Day, that's the day where we have used in a single year all the natural resources the planet Earth can offer. In 1970, it was in December the 30th, and this year, it was already in July. When you look at the population, we have about 8 billion people. We're heading to 10 billion a little bit after 2050. The good news is that the growth is reduced significantly since 1997. What's interesting is that 61% comes from the households. So it means from you, from me. And it's dramatic when you see that almost 800 million people are starving every day, 10% of the population. So carbon footprint, energy transition are important, but it's not the only problem. And I think before we really go to energy transition, we should look at the full picture. But today's issue, today's presentation is about the transition and climate change. And I would like to focus quickly on three elements. The first one are the grids, the second one is trust, and the third one is education. And I would like you to do some thinking about those enablers. We saw already from the other presentations, and especially the one from Chris, how much grids are an essential part of the energy transition. In the first presentation, there was a slide a little bit similar to mine here, where you see the mega trends we are heading towards, renewables, of course, more flexibility, unbundling, electrification. What is missing in this picture is the central role of the grids. And I would like you to, when we focus on Europe, do some thinking about this. In this slide, you see since 1998, an overview of the European regulation that we had in the energy sector. As you can see, Europe worked with packages, and we are currently focusing here, we're in this part, on the Green Deal. Interesting to know that in 2017, I published a book on European energy laws. It was about 5,000 pages. I'm working on a new edition. We're close to 9,000 pages. And is that really doable? So it brings me to the next point about grids. They are central, they are essential, but things have changed in 20 years. In 2000, when it was the beginning of the European liberalization in the energy sector, unbundling was essential. We created separately the TSOs, the DSOs, the power exchanges. Everybody went to a new life. Of course, the grids existed, but in a vertically integrated environment. All this changed in early 2000. And then in 2006, you had this UK guy, well-known, Nicola Stern, who came forward with his report on climate change. And this was a wake-up call for Europe, especially for renewables. At that time, we came with the famous marketing slogan, 20-20-20 by 2020. 20% more renewables, 20% less CO2, 20% more efficiency. Interesting also to see that that came about 10 years after the first COP, that was in Berlin. And when we look today at what has been done, as I mentioned, a lot of energy packages, quite useful in terms of liberalization. It brought interesting things. But today the focus is on climate change. And the packages that we had and the one that we still have, the Green Deal that needs to be implemented, are, I think, really far from the reality of what we need. And I'll come back to that. And when we focus on the grids, we see that they have always played a central role, but this role becomes more and more important when we look at climate change. The current framework, unbundling, funding, governance, is, I believe, totally outdated. When you look at the role of transmission and distribution grids, whether it is in gas or electricity, it's totally different than when it was in 2000. Today, grids have to be a facilitator. They have to handle significant parts of renewables. Data is key. You see the popping up of energy communities with a totally different approach to the grids. And then, of course, you also see more and more hydrogen and hydrogen grids that are playing an important role, especially when it comes to green hydrogen. The regulation, well, as you know, I'm a lawyer by training. I should have the luxury to have 4 of them. Then you have the European one, ACER, you have DG Comp, and a couple of others in related areas. Most of them are not efficient, not well staffed, not well funded, but they play a key role in this transition. And it's so important also that we say they have to be independent, but we all know this is not really true, especially in some countries. And unfortunately, the European Court of Justice recently reinforced this approach. Another big issue is, when I look at the grids, is the funding of the grids. We are still remunerating grids essentially based on the value of their assets. Of course, assets are important, but when we look at the evolution of the system, we see that services will be key and are becoming more and more important, flexibility, but all of this is not remunerated, nothing. Of course, you have a kind of, in most of the European countries, the average interruption time is remunerated to some extent, but the real service provided by the grids, whether it is distribution of transmission, is not recognized. This must change. And then when it comes to the amount of remuneration, and I'm free to say it because I'm not with a grid company anymore, I'm independent, but it's not realistic what's happening in Europe. When you see when you take the average remuneration of grids in Europe, you are around 3 to 4%. In the US, it's about 10 to 12%. With a guaranteed rate on the duration of the assets, we change it every 4 or 5 years. Are we still believing investors will continue to flow, or do we want it to be nationalized? It's a big issue. It's not addressed today. And regulators, as I said, they take a pleasure in reducing the remuneration so that they can show that cost of transition is under control. This is false. Cost of transition is not under control, and cutting the remuneration of grids is not helping the issue. And governance, as I said, I think needs a full reset. 20 years ago, distribution and transmission were supposed to be independent. Transmission could not own distribution. When you look at the current technologies of grids, is that still needed? What is important is the independence of the management of the grids. But the ownership, I think there are sufficient legal frameworks that can be adapted in order to attract whoever wants to invest in grids and make sure they cannot influence the management. Let's go to the second point. It's trust. This map of Ansoy shows how interconnected Europe is, and you saw from the slides presented by Chris from Melia how active some TSOs are when it comes to interconnectors. They are essential for the energy transmission, but it's still strange, and I'm flabbergasted when I hear important policymakers on TV claiming that we need national energy independence. When you look at the energy mix, when you see from where renewables are coming, especially for a country like Belgium, which is not really a very sunny country, and we don't have such a large territory to build a lot of renewables. We need interconnectors. So it has to be a European policy. And also interconnectors need to be funded European-wide, not just by 1 or 2 countries. Everybody benefits from it. But when we look at the current energy prices crisis, everyone is rushing for their own measures. Same story as with COVID. Instead of having a European approach, and fortunately it came with the supply of the vaccines, but it took too much time. Security of supply in Europe will only be achieved at EU-wide level, not at national level. So to get there, what you need is trust, and this trust is missing, and it's one of the key components for the energy transition. And I will finish on a couple of pictures which speak by themselves. The last one is education. For climate change, energy transition, we need to do something. A couple of weeks later in Paris, you have the yellow vest complaining about the too high energy prices, and it's an issue. But it's not only that. When you want to build wind farms, solar panels, or whatever the source, everybody is complaining. Why? People don't really know how it works, including policymakers. So, food for thought, quick conclusions. climate change, it's important, but it's not the key thing. I think we have to look also at the way we are living. Policymakers really need to do an energy reset if we want to change the climate, if we really want to be successful in energy transition. Priority should be on long-term policies and not policies that go up to the next election vision. And when it's short-term, focus on the no regrets and what is absolutely necessary. Trust, this is essential, cooperation, and education. Educate people, educate policymakers. All of this is what we try to do with Friends of Sustainable Grids. We foster the cooperation of the different grids, not just transmission, also distribution, gas, hydro. We insist on better grid remuneration, a new governance also, looking for pragmatic solutions, and very important, we try to help energy education, explaining to the guy in the street that it's not working wireless. Thank you.
Thank you, Pierre. I don't know whether you can hear us now or not, but thank you for a very interesting perspective. So it's not about only building grids, it's building trust between different parties and also educating our society and our policymakers towards the same goals. Let's go to USA with EI. I don't know, Lawrence, I think we've been having problems in communicating by voice. Can you hear us now, Lawrence? Can you hear us, Lawrence?
Yes, I can hear you. Can you hear me? Pierre is still sharing his screen, so.
Yes.
Yeah, I'm trying to unshare it, but it's not working. I will go out of the Zoom, and I will come back. Probably it will make it easier.
Okay, so we have other problems than the energy transition and the climate change. It's these technical things that we have to deal with before we can make some big plans, So anyway, I think we can go to Lawrence now. Lawrence, can you share?
Can you hear me, Ahmed?
Yes.
Okay. Well, good morning, everyone, and thanks again for having me. I'd like to just say a few words. Obviously, the technical difficulties we're having, it's a little difficult to respond to everything you're hearing. But again, thanks again for inviting me. Lawrence Jones with the Edison Electric Institute. What I'd like to do briefly here is to first just say a few words about EEI, what we do. And then I saw the slides. Like I said, I didn't hear all the words, so I'm not sure. I want to not be repetitive here, but I will still try to cover a few points that I think will hopefully lead to some discussion. So the Edison Electric Institute, we're based in Washington, D.C. We represent all the investor-owned utilities in the U.S., and then we have about 70 international members that operate in 90 countries, including GCCIA as one of our members. Together, our members serve about 3 billion people, and I want to keep that point in context here when we talk about some of the things I like to talk about in terms of population and what it means for the energy transition. There are three things, like I said, I'd like to cover. Some of them have already been discussed, the technicalities of the grid, the regulation of the grid. But there are three issues that I think are critical for the energy transition as we go forward that oftentimes is not really thought about in the conversation. The first thing is, as we talk about power system decarbonization, the first thing that I think is important to bear in mind is the issue of resilience in the context of climate change. We're seeing extreme weather events all over the world. We're seeing US, we're seeing it Australia and New Zealand. Wherever you turn, there is some issue around either storms, hurricanes, wildfires. And so I think understanding resilience is going to be key. But resilience, as you all know, is a very tricky topic. It's not a simple one, it's a very complex one that has many facets to it. And I think in the context of climate change, one of the issues around resilience is what I would call the economics of resilience. and that is who pays for resilience? How do we measure resilience? How do we get policymakers to focus on resilience? And how do we think long term? One of the things Pierre said was the idea of issues around remuneration and issues around trust. I think understanding resilience going forward is going to be extremely important in the context of what climate change is doing to the grid and what we need to do or to the energy system. The other topic, which I think is worth mentioning, is the issue of affordability. Pierre talked about the cost of grids, and he talked about the issue around remuneration. One of the challenges we have, whether it's in the US or Europe, where we go, is that there seems to be a disconnect between the value of electricity and the cost of electricity. And by that I mean everyone agrees that electrification is going to be the key to the energy transition. But the moment you begin to talk about the cost, it's all about reducing costs. And somehow we have to balance affordability with reliability and resilience. But that doesn't mean that the value of electricity needs to be rated. And to some extent, for the entire energy transition to work, it seems as though everyone is expecting the electricity sector to, carry the brunt, the burden. When in fact we know that transportation sector is extremely important. Pierre already talked about our consumption as a world. And we need to take a holistic approach to this issue of resilience and this issue of cost to really understand how we're going to move forward. The other point I'd like to make regarding the transition is Pierre talked about interconnectedness, or he talked about being integrated. One of the things I'm very concerned about is the role of short-term thinking on policy making for the world. And I'll give you two simple examples. Today, policymakers, when we talk about building infrastructure, we try to think of infrastructure from the standpoint of how can we do it cheap? How can we do it so-called cost effectively? But sometimes what is cheap and cost effective may not be resilient and the thing to do for the long term. And so I think understanding the interconnectedness of the world in which we live as we talk about the energy transition is very important. And in that vein, I want to spend some time on just two topics. One of it is supply chain. And as we discussed already in the context of COVID, it showed us how interconnected we are. Well, we know the same thing when it comes to the energy transition. Right now, it seems as though that there's a conventional wisdom that the best way to save the world is for us to all go to 100% renewable. Okay. I'm all for that. I've written 2 books on the topic of renewable, and I think it makes sense to consider that as an option. But are we really saying that we will supply electricity to this world 100% by renewable, whether be it wind or solar? If we do that, the next question is, where will we get all the energy from to produce all the renewables? We know today that one of the reasons the price of solar was going down was because of the subsidies. Obviously, there are subsidies going to different sectors, so we can't point fingers. But if we are going to manufacture most of the solar energy from one region of the world, what does that mean in terms of the long-term energy security? When in fact, we know the rare earth metals that are needed for the energy transition, if we're 100% renewable, comes from only certain countries in certain parts of the world. So we need to think about the supply chain. We need to think about what it means to go 100% renewable. And we just see right now in the UK what's happening in Europe with regards to natural gas and and renewables. And so imagine if we were to say we will not have natural gas as part of the energy mix. What happens on those days when the sun never shines or the wind never blows, as we've now seen in parts of Europe and other parts of the world? So we need to stop the either or proposition. We need to think about removing carbon from the system but we need to do it in a way that is smart. And natural gas obviously has a very important role to play in the energy transition. The question is, how do we deal with some of the issues around methane and some of the other emissions that go with it? The last point I will make, and certainly welcome any questions, has to do with what I call the role of the consumer. And Pierre talked about trust and education. I will take it one step further. I will talk about equity in terms of this global energy transition. We cannot expect the developing countries to carry the burden of reducing emissions around the world when they have not been the ones to pollute the world. What we need to do is to allow some transition that will take place faster than others. And we also need to ask the question, is it realistic to think that places that have very little development today will be able to fully develop simply using renewable energy? And we know, coming from COP26, what could happen is that the price of renewable is actually going to go up. Why? Simply because of supply and demand. If the entire world goes to Glasgow and everyone says they would like to have 10, 20, 30, 40% renewable energy, most of which is solar and wind, we will see a demand that will result in an increase in costs. So whenever I see prices, people saying the price of renewable is getting cheaper and cheaper and cheaper, I always ask myself, is this cost really reflecting the reality that's going to occur when we reach to the demand for electricity or renewables? Or will we see increases in costs? And we've already seen it this year where the price of solar has begun to go up. So I end by saying this. While we are seeing auction price for renewables very, very low, let's remember that today the demand for renewable is not to the level that I think it's supposed to go to if we're going to go 100% renewable. And the last thing is, if we do get to that demand level, will there be enough supply? And if there is not enough supply, what is going to happen? Normal economics, the price is going to go up. And so I will say, whilst we're going to head to a world with more renewables, our focus should be on diversification, resilience, which involves everything from the grid, from having a diverse supply, and then making sure the customers and the consumers and the policymakers understand the complexity of this energy transition. With that, Ahmed, I will stop here and I will take any questions either directly or via the chat box. Thank you.
Thank you, Dr. Lawrence, for a very interesting perspective. I think you've raised very important questions that we have to think about. I like the notion about being integrated versus being interconnected, which brings different dimensions of the issue of climate change and what everybody has to contribute. Also the dimension of the consumer that you brought in. I think this is a very important dimension that has to be considered. Let us go to our next panelist, Dr. Anas Dalaji. He's an engineer from Polytechnic of Tunisia. He's the project director and Middle East manager at EDF Power Systems and Transmission Engineering Center based in Abu Dhabi. So we'll be pleased to hear from you your perspective on this subject.
Thank you, Ahmed. And thank you everyone for being here, and very pleased to join you today and join all the panel and my colleagues for this discussion today. I think what I try to do probably is to summarize. I have a set of pictures to show you, to discuss, and to summarize. A lot of things already have been said and done by my colleagues, and try to summarize and give some light on some spots. So I'll be talking about the trilemma, the energy trilemma, and like Chris, Pierre Bernard, and Laurence just pointed out, and Fatima as well at the beginning, is that we need three things. We need affordable, reliable, sustainable energy to be delivered to everyone. And one first picture I wanted to show you is, by the way, this picture is not a real picture, it was somewhere in the world. But it's key to see that energy is used everywhere. There is a need for electricity. The electricity needs will grow eventually in the future. Probably they will grow further in the south than in the north. As you can see that there is a big discrepancy between north and south, and eventually this need to be addressed, and the need for affordable energy will be there in the future if we want to make sustainable future for everyone. So first things that we need to keep in mind that energy need to be affordable and available to everyone, and is one of the key things that energy system need to bear. The second one, of course, is the sustainability. Climate change, temperature that are rising all over the world, and we need to make our energy system more sustainable, greener, low carbon, in order to be there for the future generations. And this is one as well of the three main features that need to be taken care of. The third things, which is more, let's say, pragmatic, more that we feel in our day-to-day job, is to make things more secure, more reliable. No one wants to see this kind of news about outages that will happen, blackouts. So we need to make things affordable. We need to plan and operate our energy system in a clever way, especially in this changing environment that is happening so fast now. And in order to respond to this trilemma, these three key features, there is a French motto, say all for one and one for all. It's the three musketeers. So we believe that there is not one solution. There is multiple solutions. All technologies need to contribute for the solution. All the technology need to contribute for one future energy system that is sustainable, affordable, and reliable. So some picture of some technologies, and some technologies that EDF is involved in. Some of you may recognize some of our projects. PV project here in Dubai, wind project in Saudi Arabia, nuclear project in the UK. We are involved in some pump storage as well here in Dubai. This is a picture of inside our battery storage in the UK, and battery and storage is getting an increasingly importance nowadays. And of course, thermal as well will play a role. A decarbonized thermal generation, decarbonized through CCS, through hydrogen, but thermal will need to play a role as well in all the picture. So all technology will be there, will be needed. The question is how to plan in order to make everything work, to make things affordable. And of course, the second side is one for all. We need one grid to serve all these technologies. So grids will certainly play an important role. Interconnection between countries will certainly play a role. Market evolution to integrate market will certainly play a role. So the question is now how to plan, how to make regulation, how to enable investments in order to foster all this future evolution on the grid. So all for one and one for all. And of course, the trilemma that need to be solved is first, the security of supply, which is the utmost one, the affordability, and decarbonization. So if we look from one perspective, things might be easier, but we need to think the three of them. And let me finish after the Chinese motto. I'll have one Tunisian motto, let's say, from one general in front of the Alp, saying that if there is a will, there is a way. So engineers will make everything happen. If you want 100% renewable world, it will happen. The question is the cost and the time. And we need to think of all the things at the same time. Thank you very much.
Thank you, Dr. Anis. Very interesting perspective. And let us go to our final panelist, King Abdullah, Petroleum Studies and Research Center, CAPSARC. one of the leading research institutes in the area about energy. So I would like to hear his perspective regarding this subject.
Thank you very much. I have the challenge of being the last speaker, so you're probably going to be out of gas, but I'll be relatively quick. I'll speak about power sector emissions. I'll focus on Saudi Arabia for the very obvious reason. Saudi Arabia is the biggest country in the GCC, most polluting. Of course, it's not really fair to say the most polluting because it's the biggest country, so there's a size aspect there. Okay, so everything I'm going to say is not a pledge, is not a promise, it's just some scenarios and asking what if questions to see what will happen if such a scenario takes place, okay? All right, I want to introduce CAPSARC in 1 minute. It's a very long acronym. It's King Abdullah Petroleum Studies and Research Center. I got that right. We're independent. We are administratively independent. We're financially independent. We are run by our board, and we are chaired by His Royal Highness Prince Abdulaziz bin Salman, the Energy Minister. Many people think we are an engineering center because of the name. We don't have labs. We don't do any of the physical sciences. We just do social sciences and economics and sustainability, so the soft sciences. We're 60 researchers coming from 20 countries. And I really want to share this with you. We have a data portal on our website. Thousands and thousands of data sets. They're free. So energy consumption in the region, solar installations globally, gas offtake, transmission. So visit our data portal. It's free. It's downloadable. You don't even have to reference us. Well, it's nice if you cite us, but you know, if it's free data, download it. But of course, we don't share any proprietary data, any confidential data. But you know, please make your data portal in CAPSARC your first stop to look for data, whether in the region or globally. So data portal at CAPSARC. Remember that. All right. So I'll talk about emissions in Saudi Arabia. Everybody knows this slide. So the current mix in Saudi Arabia is around half and half, right? Liquids and gas. His Royal Highness has announced that by 2030, the mix is going to change. So His Royal Highness mentioned that we will have no more liquids. It will be 50% renewables and 50% gas. So that's the aspiration. And it's 9 years from now. Okay, so what we wanted to see, okay, the base case, the business as usual scenario is Saudi Arabia continuing to rely on liquid fuels and gas. We simulated two scenarios, and you know, we thought of them rather carefully, although they seem very simple scenarios, but they will give you very, very profound insights. First scenario is retire liquids and keep the gas price as is, $1.25 per MMBTU. The second scenario, increase the gas price. It's not even reaching Henry Hub prices, but this is what the EIA projects up to 2030. So around $3 per MMBTU, right? So just remember these scenarios. We have a base case, we have a low gas scenario, and we have a high gas scenario. And let's look at what would happen. So current consumption in the kingdom is around 300 terawatt hours, and the peak load is around 60. You know, you compare this peak load, you know, it's 3, 4, 5 in Bahrain, it's around, you know, less than 10 in Kuwait, and it's really small in the other GCC countries compared to 60 gigawatts in the kingdom and around 70 gigawatts of power generation capacity. So we will reach around 520 terawatt hours in 2040. Of course, we can give and take. This has been along the SG model, population growth, energy growth, and that's what the number tells you. Of course, we can give and take, but again, we want directionally to look at the insights. So let's look at the first result. How we did that, we have a detailed power sector model for the kingdom, all the generators, all the transmission, all the efficiencies, etc. The candidate technologies, as we agreed, we retired liquid, so we only end up with renewables and gas. So we have solar, we have wind, we have CSP, we have storage, we have nuclear, we have gas. So these are the candidate technologies that we will be building to satisfy our demand. Let's look at our generation builds. So first case on the left, that's the business as usual. Nothing really fancy there. Gas and liquids, because it's the business as usual. The model doesn't build renewables despite the fact that renewables are becoming cheaper. because the prices of liquid gas is relatively low. Low gas price, same scenario approximately, the model builds very little renewables. When we look at the high gas price scenario, the model builds 70 gigawatts of solar PV. So just raising the prices from 1.25 to around $3 per MMBTU, we build around 70 gigawatts of PV. So can you guess what the emissions would be before I go to the next slide? Where will the scenario be with the lowest emissions? Probably the third scenario, right? So let's look at emissions. And this is probably the most important slide that I wanted to share today. Given that we're talking about climate change, we're talking about emissions. In the base case, emissions rise to around 280 million tons. In the second case, where we retire liquids and we only introduce new gas fire plant, very efficient combined cycle and efficient single cycle, emissions drop down to 210. But emissions drop to around 160 in the third scenario because the model builds what? 70 gigawatts of PV. So emissions really go down. So imagine you reduce emissions by around 100 million tons just from Saudi Arabia. And this is only by raising the gas price just a little bit. So $3 is more than double of 1.25, but it's not even as high as 4 or 5 or 6 prices globally available. This is an interesting result from the model. We talk about interconnection. Saudi Arabia is actually big enough to, you can actually say that when you're interconnecting the eastern region to the western region, that's an interconnecting by itself. If you connect, Dammam to Qatar, it is an interconnector and it's cross-border, but it's not like connecting Qatar to Asir or Qatar to Jeddah, or sorry, Dammam to Jeddah, right? So you can actually say that this is an interconnector. In the model, we find that the only line that is being built, and mind you, it doesn't actually choose to build a generation plant, for example, somewhere. No, it builds a transmission line between the eastern region on the right and the southern region. It actually chooses to build that. And when does it build it? It builds it in 2029. Why? Because, liquid retirement happens 2030. So by 2029, the model builds that. And the southern region is fully reliant on liquid fuels. So when you retire liquid fuels by 2030, the model builds that transmission line in 2029. That's the only line that's built. It doesn't build a gas pipeline. So transmission, you can think of it as actually better interconnection. It's probably most probably a cheaper option or a more cost-effective option than building, for example, a gas pipeline. Something to think about. And this is my most beautiful slide. When I showed this slide to one of my colleagues, he said, Amr, you have a mistake. He said, slide 15 is empty. You forgot to add content there. And I didn't. We have been hearing the notion of when you have a lot of renewables, what is it that you need to complement it? Storage. You need storage. That's the classical cliche. In our modeling, the model doesn't choose to build any storage. It actually chooses to build transmission interconnection. And you only need storage if you have a lot of renewables and you have oversupply and there's nowhere to do it. You either dump it or store it. But if you're going to be using every electron or all the energy that's being supplied, you don't need storage. The model chooses the interconnection between the eastern region and the southern region and doesn't choose to build storage. So I know it's counterintuitive. It's probably, if you're a storage proponent, if you're a storage champion, you're not going to like this result. But we're as objective as possible. This is what the model tells us. But the insight is this cliche, this repetitive session or statement that we need storage to complement renewables. That's not necessarily the case. Gas is very, very efficient. Gas is very good in terms of ramping. So if you have a good amount of gas, you might actually get away without having storage. So again, I'm really very proud of this slide. It's beautiful. All right. In terms of gas offtake, again, let's look at the consumption of gas in 2019. This is the actual number. So around 2.2 trillion BTUs. That was the consumed gas in the kingdom in 2019. In the third scenario, when we increase the price of gas, what's the gas consumption in 2040? It's 2.4. So now, rising to 500 terawatt hours and more, but what's the gas consumption? It's almost the same. So this has huge implications. This means that Saudi Arabia does not necessarily need to invest in additional gas supply. It's the same supply 20 years from now. This is very important. So you can build solar and not invest in any additional gas supply or gas fields. Very, very interesting insight. And you know, the government wants to make a decision. Should I build renewables or build more gas supply fields? So and here it's probably either or, you know, because it's not cheap to build a gas field or build the gas pipeline infrastructure. What is the equivalent carbon tax? So we worked out backwards. What would be the equivalent carbon tax if one would be ordained? Again, this is just a mathematical exercise. In our renewables retirement, it's around $20 per ton. That's how much would be needed for that scenario to befall. For the renewable, for the high gas price, the approximate cost of carbon would be around $50 per ton. So again, something, you know, ballpark, it's relevant and close to what is what's happening in Europe. Not in Sweden. Sweden is very high, but you know, these are the numbers that are generally floating around globally within these ranges. I'll just leave you away with that. You know, two main key takeaways. Number one, more renewables does not mean more storage. Yes, I know that this is something that has been said. You find a lot in the literature, but not always. It really depends. Finally, again, another important thing is if you have more more demand, if your energy demand is growing, that doesn't necessarily mean you would need more gas, at least in the Saudi context. And of course, you can extrapolate that into other contexts. I'll leave you with that. Thank you very much, and happy to take questions after we're done. Thank you.
Thank you, Dr. Amr. That's very interesting, and I like the notion of the findings that you say you close with. You know, that more renewables does not necessarily more storage, which is a classic idea that we have. But I'm glad that it means that you need more interconnections, which means the grid. You know, the grid is the storage, actually. Yeah. Okay, thank you very much. Maybe we'll go in a round of questions for our panelists. And we'll start with Engineer Fatma. Now, there are plans now to build these large solar farms. You're reaching about 2 gigawatts of solar, which will be built in Abu Dhabi. And now with this kind of large scale renewables coming in, what are the plans for, how do you deal with the system security, the inertia? What is the kind of thing that needs to be done in terms of integrating? Are you counting on interconnectors? Are there plans for having more interconnectors in the neighboring countries? How do you plan to manage that?
Definitely, as what I have discussed in the beginning, and my colleague also, it's a challenging, and that lead us to the also what Lawrence mentioned. Is it possible to have 100% renewable? It is possible, but there is a compromise on other dimension of the energy sector that we are concerned with regard to number one, energy security. For Abu Dhabi, as you are aware, we don't focus only on renewable. We analyze the energy mix as a whole, and we have the base load, the nuclear base load that is covering actually the base load required for the grid, which is a solution and not the only solution for this case. but also we are dependent on the expansion of the GCCIA, that we hope this will open also possibility to utilize our maybe sometime curtailed power, but also excess power during winter with us. The experience of the GCCIA to expand for other countries which has different load profile than what we have on the GCC will be a good storage for our electricity. As Dr. Amr mentioned, it's a storage. That's definitely another part. What we are developing is also the which is under, of course, study, the hydrogen mega plant that also will lead to additional conversion of the electric power to another source of energy utilization.
Thank you, Engineer Fatma. And I think this also brings the, as you said, the one for all and all for one, because coming together with the GCC countries, I think we need to support each other within the grid. Chris, I think one of the things that you mentioned is that we need to build more and more interconnectors. I know that you are doing that in Belgium. We visited the Nemo link with England, and you have just commissioned another link, and this is part of your. But how about choosing some model which can be something for the whole of Europe? I mean, there are bilateral interconnectors being built, but how about a holistic look at the interconnector? Something like resembles a supergrid or a unified supergrid, maybe run or coordinated by one entity. Is this achievable in Europe? Do you see it a model that can be pursued and maybe implemented in Europe? Maybe you just take the whole thing.
Okay. In theory, it looks like a nice idea, but in practice, we don't have the time for it. So what you see, if you want to go to such a system, it takes an enormous amount of time in coordination. You have, of course, different interests of different member states in Europe. So it's a very, very complicated road to go there. And so the vision that Ilya has is that you need to strive to that, but you need to move forward in parallel. And that's why you see that we have this high level of investments that we do in interconnectors, because we say we're not going to wait until somebody has an overall view of what it needs to be. We already have problems today. Let's make sure that we address them. Let's make sure that we invest. I give a nice example of that. We have the first and the only hybrid interconnector in Europe that we operate between Denmark and Germany. If you look at all those packages that Pierre talked about that are coming from Europe, one of them says you need to use at least 70% of your capacity of an interconnector for commercial interconnection. If you feed wind into that, you want to have, of course, that the wind has a priority to that interconnection. So there is a flaw in that law. We asked for an exempt and we moved forward. And now we're looking at how should we regulate that going forward, because we didn't think it was wise to wait until we had a theoretical view before we should invest. We said, we learn from the investment itself and then use it as an input into the way how we best regulate things. The same for the island. We said the island is a good idea. It's an energy hub. It has a lot of opportunities. Once we do that, we will learn, and that will be input for that regulation that evolves. But we don't think that you have to first go only to wait until you have the ideal model, because the ideal model will never exist. It will be some target that you always try to aim at while progressing already with what you do today.
But it seems we have to a little bit change the way that we're doing things in terms of our business model. That will be affected by this, isn't it?
Well, it will be affected, and you don't hear me say that grid development is not an important activity. It's one of the most important activities that we do as a company, keeping the lights on and do grid development activities. But waiting until a central entity says so, that's not what we do. We do our own studies and we define what is possible. We look for bilateral relationships, start to build on that. look at other relationships and connect people together. So we create the roundtables that we want to have before we see them happening by any, let's say, central coordination role. And I think you will see more of this happening. Of course, in the end, you could say Ilya has a very central role, and that's true. And that's what we see as the logic. We have a very central role. We help Europe to realize their objectives. And if at some point of time they change them to progress with good grid development, with good ideas of new interconnectors, propose them, calculate them, find the partners to realize them, and move forward. That's what we do.
I know that you have developed the Corezo Center, which is for security evaluation. Do you see the role of this maybe increasing more towards planning aspect for this kind to achieve like optimal ways of planning interconnectors?
We have seen in the last wave that the role is increasing, but they are in the time window which is until day -1. So that's the time slot they focus on. We don't see them that much into grid planning yet, because there you see that the bilateral relationships that you have are more relevant than the one that you have. And so we do something like the 10-year planning that we do. That's a place where we coordinate some of the activity, but already there you see today that a lot of politics are happening, and so it's very difficult to coordinate it on that level. So I think in the end it is about trust. I think that Pierre said it as well. It's about trust. So you need to find partners that trust each other and that want to go in a venture, because it's always a big venture, such an investment, that you say we are here in for the long run and we partner with each other and we make it happen.
Okay. Thank you. Pierre, I don't know whether you hear us or not. Can you hear us? I'm not sure if Pierre can hear us. Okay, let's go to Anas now. You said about being affordable, reliable.
Yes, I can. Yeah. I follow you on.
Okay, fantastic, Pierre. So you've heard some of our discussions here, and we like
YouTube
the notion
with
that,
delay.
Yeah, I think we have to deal with that a little bit. I think you expanded the focus about the grid to be something about having trust and educating the people, maybe the customer, but also the policymakers. It is really a challenging matter that we need to achieve, because these are different dimensions. So how do you bring it together? And especially, what is the role of the friends of the sustainable grids in achieving that? Not only focusing on the grids, but how do we expand it to have this trust and to expand it towards the education of the community and the policymakers?
Thank you for the question. Thank you also to the panelists for supporting the view that grids are central and essential. And I'm sure Chris shares the view more than everyone else. It's a little bit difficult to speak with this echo. No echo anymore. To answer your question, Ahmed, with friends, we go bilateral to policymakers and spend some time really explaining the basics. as Chris said, you cannot wait to do some projects that everybody has understood why you do it. So being a non-profit, we take the time.
You can lower the volume here. Maybe you can lower the volume of the broadcast while you're speaking so that you don't hear the echo from your side.
I lost you guys, sorry.
This is one of the COVID side effects, you know, that you have this kind of hybrid issues, technical issues. We can hear you.
Is that better?
Yes.
But then I hear nothing anymore.
But we can hear you. I have to learn some sign language for the next forum.
Yeah, me too, with some delay. Apologies again for this. That's much better.
Okay, we can continue.
Me too.
Just receive the joke. Okay, can you continue, Pierre, with your answer? Okay. Okay, Pierre, can we go to Lawrence?
Pierre, turn off your sound on. Turn off your sound on YouTube, and just go ahead and talk.
Okay, I'm going to do it like that.
Turn up the sound, and then you can just go ahead, and then you can switch back afterwards.
Okay, thank you, Lawrence. I hear you well, by the way. But anyway.
Yeah, because you.
Yeah. No, what I was saying is that we try to have as much as possible bilateral contacts with policymakers, focusing on a couple of items. And it has worked well until now, but it's taking an awful lot of time. And one of the main issues is that policymakers, for the reasons we know, are looking at short-term solutions. And I think besides explaining how the grid is functioning and what is needed, the key element here is to be able to bring them to take decisions on more than 3, 4, 5 years vision. We need long-term decisions, and when you're talking about interconnectors, grid planning, permitting, etc., it all needs long-term, and we are losing a tremendous amount of time, and this losing of time is very expensive.
Okay, thank you, Pierre. Let's go to Dr. Lawrence. Lawrence, regarding what EI is achieving, I like the notion of needing to be integrated versus needing to be only interconnected. I think this gives a more holistic approach towards achieving climate change objectives. You talked about the role of consumers. How can EI contribute to this? You know, I know that you're targeting like policymakers, strategists. policymaker, strategist. Now, how do EI contribute towards achieving this kind of holistic approach to achieve climate change objectives?
For the question, Ahmed. So there are a couple of things that we do. First of all, I think we focus really on three aspects: working very closely with regulators, working very closely with consumers, but also working very closely with investors. I think one of the challenges facing the energy transition in terms of the kind of holistic collaboration that I think is necessary is, like what Pierre said, too many short-term thinking, a lot of focus on just quick wins. So one of the things we do at EEI through the different forums we put together is to try to push the envelope by bringing people from different backgrounds to come together. So for example, when we have an event, we typically do not just want to speak to electrical engineers or power system experts or people who are in the industry. So we will reach out to people from the transportation sector, from the even from the media, from Hollywood, people from different sectors, because energy is a very complex issue, and I think oftentimes we as an industry, we spend too much time focusing on just the technical aspect of energy. I think increasingly it's going to be very important at EI. We are focusing now on what we call the multi-pronged approach towards policy making, where, and I'll be speaking about this in the next couple of weeks actually, where the focus is bring the water sector. If you think of what's happening regarding water, it's going to be a critical resource going forward. Think about the transportation sector. Think about the agricultural sector, because the business model for energy systems is not going to be sustained basically on selling electricity. We're going to have to think about selling different electricity-enabled services. I think the other point I will make with regards to not just what EI is doing, but what I think we need to do as a global community as it relates to the issue of the energy transition is we need to have a, what I call, honest conversation with consumers, but also with policymakers. You know, a transmission line, as we all know, takes many years to build. But today, if you try to discuss building a transmission line, there are those who will say off-grid solutions are the best thing to do because you can bypass the grid. Well, it is good to bypass the grid until there is a major storm or there is a major disaster. Then everybody else wants the grid. So my key message at EEI, when I talk to utility executives around the world, but even in this sort of a forum, is something I have been saying for the last couple of years, and that is we should simplify the message of energy, but we should not trivialize the problem of energy. And I think too often times we try to trivialize the problem by coming up with a very simple slogan, a very simple slide. For example, it was great to hear the gentleman from CAPSAC says, well, you don't need energy storage or something similar to that if you have a lot of maybe gas or you have interconnectors. I think it's a very missed opportunity, because once you say that, the media picks it up and will say, the gentleman from CAPSAC said that you don't need this if you have that. Well, I think we should get away from that kind of a conversation. It's no longer about we don't need this or we don't need that. We need everything. Why we need everything? Because the world is different. Some places will need storage, other places will need interconnectors, other places will need both. I think we should as a global industry, and this is what I discuss all over the world when I talk to people, do not use either or statements, because once you do that, a policymaker in one country will hear what you say in another country and they will use it. So we need to think as a global industry that the message I convey in the United States as a policymaker has an impact to what they do in Belgium, has an impact to what they do in Saudi Arabia. So I didn't want to beat up my friend from COPSAC, but I think we should be very careful not to use phrases like we don't need this if we have that. We need everything. We need everything done in a systems approach. Every country has a different foundation. Therefore, we as experts should be very careful in saying one thing is not good, the other thing is better. We need to think holistically. Thanks, Ahmed.
Thank you, Dr. Lawrence, for a very interesting perspective. Let's go to Dr. Anis. Now, as EDF is here in the region, I think you realize the importance of international cooperation in order to achieve plans, especially for climate change, which is a global thing that needs to be having collaboration from all aspects. How does the EDF contribute to this? How are you approaching this kind of international collaboration, and what is your role in doing that by activating research and things in this area?
Thank you, Ahmed. Thank you, Ahmed. Yes, so EDF is present in the region since 1994, I think. At that time, we were helping in Abu Dhabi to build the dispatching center at that point in Abu Dhabi, and then we came as well to Dubai for the ENG project, or for the interconnection as well between this country, and since then we are present in the region, helping in different projects. Now investor in different generation low carbon projects within the region, and EDF is indeed present in all continents, developing mainly low carbon technologies, leveraging our R&D departments. We have 2,000 engineers in different sites, looking into different fields on research and development. And like Mr. Lawrence said, I mean, one of the key aspects as well to address in the energy sector is not just the technical, but also the sociological aspect. So we are looking as well onto this sociological aspect of the energy transition and the impact of energy transition on different social categories. So and we'll see that having this international exposure give us also a good view on different situations around the world, and different situations that can be applied elsewhere. So let me take an example to make things more concrete. We are working with New Caledonia, which is an island in the Pacific, to help them to achieve 100% renewable in the island. Of course, it's a specific case. It's an island with in a tropical environment with some resources that are specific. But the learning that we have there in terms of operating a grid with no inertia or very low inertia, of building overhead lines and cables on this environment, we bring this knowledge as well here in the region. We are looking of great opportunities. For example, in Saudi Arabia, we are looking into how to operate a system with low inertia as well in the region, with a huge integration of PV. So the learning that we have all around the world, we try to bring it in all the other countries, and we are proud to be here with our partners to achieve that.
Thank you very much. Go to Dr. Amro. Very challenging targets for Saudi Arabia to achieve 50% of renewables by 2030. 2030 is just around the corner. Is this really achievable, and what kind of enablers will have to be done? I mean, we heard from Lawrence, for instance, saying that with the higher demand that will happen on renewables, the prices might be going also actually the other way, that prices of renewables might be going up because of the higher demand. How would that affect the plans of Saudi Arabia, for instance, to go that? Would it make the real economic viability? This is one. And what is the plan for Saudi Arabia in terms of building interconnectors, since interconnectors is seen as a very much needed, element of this formula?
All right. The second part of the question is easy, and the answer is I don't know, because this is beyond my paycheck. What are the plans for the kingdom? And as you know better than me, what are the plans and what will happen regionally between the interconnections and how the costs will be incurred and how it will be shared. But in terms of the aspirations of the kingdom, His Royal Highness was very clear. He has announced on several occasions that the energy mix in the kingdom will be 50-50 by 2030. Is this achievable? Well, you look at the recent announcements that have been per kilowatt hour. We're talking about the Shu'aiba plant. We're talking about Mecca, Sa'id, Sudair. We're talking about so many projects in the coming 2 to 3 years. I always cite this example. Back in 2018, if I remember correctly, China built 13 gigawatts of PV in June. So in 1 month, China built 13 gigawatts. Of course, we understand that it's China and the dynamics are very different, and the manufacturing capacity is there and the supply chain is there. However, you look at Repdo, you look at KK, you look at the organizations in the kingdom, and it is around the corner. Is it achievable? I think it is. Is it challenging? The answer is yes. But we're seeing a lot of progress. We're seeing a lot of work on the ground currently as we speak. So let's be hopeful and optimistic that at least, even if we miss the target, we'll miss it by a small margin.
Maybe we'll open the floor for questions or comments from the audience, our attending audience. Any questions that you would like to raise to our panelists? Yes, please.
Good afternoon. I'd like to thank. Is it on?
It's not working. Can you turn it on?
Hello? Hi, can you hear me?
Okay.
I'd like to start with thanking the panelists for your interesting perspectives and insights. I have a couple of questions. One is to all the panelists, since most of you talked about the importance of grid adoption and infrastructure in defining this transition and enabling it. But I'd like to talk about the energy market. I know it's quite in its infancy in the GCC, but what do you think of this opportunity and the possibility of commercializing it, and how that could potentially change the dynamics in terms of the incentives for policymakers, for investors, and even for consumers? Do you see this as something very critical in driving the adoption of grids and of renewables in the region? And my second question is specifically to Dr. Amro. I know you talked about your perspective on how batteries and storage are not essential to to the Saudi Arabia in particular's renewable strategy. I wanted to know your perspective on whether or not you think it's possible to participate in the energy trading market in an instantaneous sense. I don't know if that's technically possible, and if not, based on transmission and not storage. And if not, then do you think it's still worth looking into? Thank you.
Thank you very much. I think a very interesting question. Let me save the second one for Dr. Amr, because this is for you. If I may comment, I think energy market is a very important element, in this, I mean, it enables the utilization of the interconnectors in the right way. For instance, here we are in the GCCIA building platform of the energy market, the electricity market, with different parts of the market, and we think this is very critical for better utilization of the interconnectors. And this will be the basis for our internal trading. In addition, in the future, it will be also opened up and coupled up with the regional market. So from our perspective as GCCIA, we think the energy market is a very important element that also needs the attention to be given. So I'd like to give the floor for our panelists also to comment on this. You may choose to comment on this.
I think indeed that is a very important aspect if you want in an efficient way to make it an energy transition. And if you look at the past, we have already in Europe in the way how it functions. If you see, for instance, we started with a model where you had a concept that you can compare with a single buyer concept. And with that single buyer concept, there was not a lot of market functioning. And actually what we did in the first place was making sure that there was a market which was based on day-ahead prices, where you could then make sure that the most competitive entity was playing its role. But in the initial phase, we still had a separate use of the capacity reservation and the use of that capacity, so which made it an inefficient market. And we moved further towards market coupling, where we combined the capacity of the interconnector then with the use and the matching of supply and demand. And what we're doing today within Elia is going the next step. And the next step is that we ensure that the market access for the end consumer becomes much more easy, and that they are not with a protection vis-à-vis the wholesale market in terms of having many intermediaries. They still need to be protected, of course, for low and high prices. That's what we've seen in Texas, that you should be very careful if you open it up fully. But you could actually, with a floor and a cap, expose them to price signals to ensure that their behavior, especially now that we see in Europe that more and more, say, appliances are electrifying, vehicles and mobility is electrifying, you see heating that is electrifying, and so you need to give them more signals so that they adjust their behavior to the reality that you see happening on your system. And that is actually a very efficient way to run your system, because on the one hand they get the benefit if they adapt their behavior, if they charge their car at the moment that we have a lot of sun. On the other hand, of course, it also helps us to better manage the grid, because we use the capacity that we have in an optimal way. We should less fast invest, because the capacity is better used over time, and so consumption is spread in a more stable way than what you would have if people can consume whenever they want. And so that's why we try now to get market signals really to end consumers, not only to the large industries, but also to the individual end consumers, to ensure that we have an optimal behavior vis-à-vis that availability of renewables on the system.
Thank
you. Just to add the perspective from the region, as Ahmed Ibrahim mentioned, the GCCIA is supporting. The thing is, definitely the market will help the optimization of operation. Going back to Dr. Lawrence, word that
just to add the perspective from the region,
as Dr. Lawrence mentioned, trust is required, and that need to be built. The thing is, if we talk about market or energy market, we have to talk about market liberalization, and we are in different stage within this region, in either single buyer or somehow market liberalized, and some still having the government ownership 100%. It's a different, we are in different stage, and this will need to work on market liberalization. That also would have another perspective where you are on the existing power purchase agreement. It's good, it's for optimization, but to make a decision you need to analyze different where you are from liberalization, where you are from existing contract that has been signed as a BBA. this kind of analysis need to be conducted for optimization is the ultimate goal.
Thank you. Any other response from panelists? Yes.
Just compliment and open the floor to Omar for the storage. And just to say that indeed in Europe there was a lot of stages and in order to come to this stage of liberalization and to answer your question on about attracting investor, for example, for battery storage in Europe, having markets that are well developed, having different markets, not just energy market, but also capacity markets, ancillary services market is one of the enablers that led to development of some battery storage development, especially in the UK, for example, where there is some battery storage that were developed there. So definitely having a well-developed market will help to attract investors in that perspective.
You had something to So maybe we go to Dr. Amru to respond to this and the part two of the question.
Thank you. I believe your words were, I said that storage is not important. That's not what I said. What I said that the model does not choose to build storage. So two very different things. And again, this also brings me to Dr. Lawrence's
just a quick comment
and,
on what was said on the markets. I think some people might react with strange eyes or ears when they will hear what I say. I think here also we need to do some reset and revisiting. What we see in the recent energy prices crisis shows that the governments are not prepared to let market play the way market should play when it comes to something like power or electricity and even gas. Today and certainly tomorrow, electricity will be the central commodity. Without electricity, you have nothing. You have no internet. Without internet, you have no access to your banking data. You have nothing. If you have nothing, the system is not working. And I think here we should start doing some thinking with a different role of government, and in Europe, especially European government. I think the current market rules are not functioning. In the market we are heading towards 100% renewables, and certainly not with the central role of electricity.
Can I make a comment? That's all. Good. So just two quick comments. I think we should also, I'm very nervous when I hear us talk about markets, especially for a commodity that is not a normal commodity, right? I mean, electricity is not a normal commodity. So while I believe, the notion of liberalization and creating markets, these are all very good, noble concepts. But what happens whenever the market has an issue? We have political intervention. We see it right now in Europe where we have price caps. I mean, if it was a market, the price is going up. The market should find a way to self-regulate because the market rules will work. But unfortunately, because electricity is not, like Pierre said, is such a central commodity, it's really not a normal commodity. And so I think we should be very careful not to overuse economic concepts from other types of pure supply-demand market, as opposed to what I call supply, demand, regulation, and political. Those are the four things that make electricity very complex. So right now, if you look everywhere in the world, wherever there is a crisis in the electricity sector, the first thing that happens, there's a political intervention that comes in and says, let's redesign the market, let's reset the market. Well, maybe the market is working the way it's supposed to work. Maybe the market doesn't have to be redesigned. Maybe what needs to be redesigned is the political intervention in the markets that create the problem. So I strongly believe as an industry, global industry, we need to have a conversation with regulators and policymakers to say, stop beating on the sector. Every time there's a problem, the first thing you do, you say, well, the capacity market isn't working. Well, maybe we don't need a capacity market, because guess what? Electricity is not the same kind of a commodity. I'm not saying we shouldn't have it, but I think we need to be very careful with how we underestimate the power of politics in affecting what the markets does. Thanks.
Thank you, Dr. Lawrence. Very interesting indeed. We go to Dr. Amro again.
Thank you. So I'll start again. You mentioned that I said the storage is not important. As I said, so this is not what I said. I said the model doesn't choose to build storage, and these are two very different things. Again, this brings me again to elaborate. I beg to respectfully disagree with Dr. Lawrence. If you are in front of a policymaker and a policymaker asks you, what should I do with the power mix B by 2040? The answer is, we need everything. This is not a scientific answer, and I promise you, you'll be probably kicked out of the room. We're independent in CAPSARC, and because we're independent in CAPSARC, we can say things like X technology is not economic, or X technology is economic. And it is up to the policymaker to choose. I have been in front of policymakers where we have provided 3 or 4 options, and in many instances the policymaker will choose the non-least cost option for other constraints. But it is extremely important to tell him that this is the most economic option. And so, for example, use everything. So geothermal has been around for decades. Does this mean we have to use geothermal just because it exists? No. You choose the technology that says, I'm here and I can deliver. Now, if we have the assumptions, the paper is published, available online, the journal version, the journal version, the CAPSARC version. If your carbon constraint changes, then your energy mix will change. If your costs of batteries change, then your energy mix will change. But the cost is always there to tell you, I am here. Yes, can we have a renewable world? Absolutely. We have 6 terawatt capacity approximately globally. So if you want to replace the whole world with the renewables, you probably need 12 to 15 terawatts given the capacity factor. Can we build 12 or 15 terawatts of renewables of solar and wind? Yes, we can. Can you pay for it? That's the question. So to answer your question, basically, storage is currently not cost competitive. Will it be cost competitive next year if somebody, in a garage in India or in, Silicon Valley comes up with a completely new technology and changes the paradigm? Things will change. Yes.
Thank you. I think we are out of time. I hate to conclude at this stage while the discussion have just started to heat up. But I think this also opens the door for more questions to be answered, in our mind. And I think in this forum, we've managed to open the eyes on many subjects, many aspects of the issue itself. We've seen that it's a global issue. It's a global issue not only geographically, but it's also in different dimensions. And we see that it's not only the energy sector, it's not only the grids, it's multiple dimensions of issues that interact together so that we can achieve that. So it's really quite complex. We need to really collaborate in this sense. But as Dr. Anis said, if there is a will, there is a way. But there is a need to collaborate more between countries, between different sectors in order to achieve this. And when Dr. Lawrence says we need everything, I agree in concept that we have to consider every solution, because the right solution, we need to have the right solution for the right situation at the right time. So that's why we have to look at all technologies, all solutions, but we select whatever the right solution for the right time, for the right conditions. And I think this is the way that we do. But the bottom line is that collaboration in all aspects, horizontally and vertically, is needed so that we can achieve this. And being here in Expo Dubai, I think this is a central role of bringing people together, bringing countries together, bringing nations together to achieve common goals. And in this case, climate change is a very important objective that we need all to collaborate to change. At the end, I'd like to sincerely thank all of our distinguished panelists who have given us valuable feedback and responses, and would like to give them a small token of our appreciation at the end of this one, and I'd like to thank you all for being here and for attending this forum. Thank you.
Thank you, Engineer Ahmed Al-Ibrahim. Thank you, Engineer Al-Shamisi. Thank you, gentlemen. Last but not least, on behalf of GCCIA, I would like to thank the Gulf Cooperation for Arab States for hosting this panel on climate change and energy security. I would like now to invite Engineer Ahmed Al-Ibrahim, CEO of GCCIA, and Mr. Khalid Al-Sheikh, Commissioner General of Gulf Cooperation Council Pavilion, to honor. Let's start with Engineer Fatima Al-Fora Al-Shamisi, Energy Policy Executive Director at the Department of Energy in Abu Dhabi. Thank you, Engineer Al-Shamisi. Now I would like to invite Engineer Chris Peters, the CEO of Elia Group, to be honored by the gentleman. Unfortunately, Mr. Pierre Bernard, CEO of FOSG, and Dr. Lawrence Jones, Vice President, International Program of Edison Electric Institute in the U.S., their token of appreciation will be sent to them shortly by GCCIA.
We'll give you the token of appreciation when I meet you next time, which I hope to be very soon.
Now I would like to invite Dr. Anas Dalagi, Project Director and Middle East Manager at EDF, to accept the token of appreciation. And now I would like to invite Dr. Amro Al-Shurafa, the Research Fellow in King Abdullah Petroleum Studies and Research Center, to be honored by Engineer Ahmed Al-Ibrahim and Mr. Khalid Al-Sheikh.
I'd like to thank the GCC Secretary General for hosting us here, and our friend Mr. Khalid Sheikh for all the efforts from the GCC for hosting us in this event, and being here. I think it's a proud moment for us to showcase the GCC achievement that has happened over the years. So thank you very much.
We would like the participants and Mr. Al-Sheikh to have a group photo for the panel. Yeah, please. Ladies and gentlemen, we would like you all to feel free to tour the pavilion, the GCC pavilion, at your convenience. We will take you on a group tour straight after concluding the panel.